Hello, and welcome to my tutorial for a 3D character editor in Godot 4. One feature of this character editor is that it supports meshes that depend on the shape of other meshes. For instance, when I edit the body in this demonstration, the pants mesh is replaced with one that does not intersect with the body. The hair mesh is not replaced by another when I edit the body because there is no need, as the heads are identical between the body options. By the way, the character does this little dance to demonstrate that the skeleton and animations work as I edit the model. I split this tutorial into a couple of parts. The first part is an overview of the method I used without going into the nitty-gritty of how it works, followed by a detailed section where I go over my code line by line and break it down. I would write all of the code from scratch on camera for you as I explain it, except there are 240 something lines of code that you would have to sit and wait for me to type. Even if you only care about the detailed explanation, I suggest you watch the simple part anyway, as it contains some important information I will gloss over in the complicated half of the video. The most important thing is how you set up the character tree. From the top, I have a node 3D, then a skeleton node. The meta rig node is an unnecessary byproduct of using Blender to rig my model. I could have deleted it, except I didn't do that. After the skeleton node, I have two organizational nodes which contain several mesh options for the hair and body. The body mesh options expand into more organizational nodes, which there can be any amount of. For this tutorial, I only have one, the pants node. These organizational nodes then expand into more mesh options. All child nodes of the body nodes must be identical. The names of the nodes have to be the same, and so does the structure of the children. For example, if one node has children and the other doesn't, or they have different names, you will run into errors, at least if you follow my code. There can also be only one node visible per cosmetic item, or you'll get mesh clipping. Now that we have the character set up correctly, the way that this method works is that when an option is pressed, for example the Hair Next button, the current hair node is hidden and the next is shown. The same goes for the pants, but when you change the body, you must also enable the proper pants node, or your character could go from wearing pants to wearing much shorter pants. The way I handled changing color is that I have material resources in the file system that I assigned to the cosmetic items. Resources in the file system persist across scenes, so I didn't have to write any extra code to handle that. As for the character persisting across scenes, I stored it in an auto-load singleton and loaded it into the new scenes, but only after going through each node in the character tree and deleting it if it is hidden. I also built a dictionary in the global autoload, which I can use to re-enable the different cosmetic items in the character editor when opened. The way I have this scene set up is that there is a UI with left and right arrows, a color picker, and a label for each cosmetic element. I also have environment nodes, and then finally, I have the node for managing the character editor. The character itself is a child of that, and there's a script attached that most of our code will go into. Without further ado, let's jump in. I have several variables for each cosmetic element here at the top. For the hair and body elements, I have the node that is the parent of each, the UI label node, the UI color picker node, and then finally, the material resource. The pants variables are slightly different because there is not just one parent node for the pants mesh nodes. So we give it the name of the parent node of the pants and declare an empty array of nodes that we will populate in the ready function with the two pants parent nodes. We also need to access the skeleton node because it is the parent of both the hair and body parent nodes, essentially the root of all the important nodes in the character. We also need the node that contains all character nodes, not just the important ones. We also initialize this dictionary, which will include the names and parents of all the enabled nodes when we save and exit the character editor. In the ready function, we first check whether the global auto-load dictionary with all enabled cosmetics is already populated. If it is, we want to enable the correct nodes for each key. For example, if the dictionary contains the key hair with the assignment hair 01, it searches the node tree for the node called hair and enables the child of that node with the name hair 02 and disables the other children. I will go over the enable from dict function later. In the variables, we initialized an array that would contain the pants parent nodes, but we did not populate it. We do that here by looking at each child of each body node, and if that child has the same name as pants parent name, we add that child node to the array. We also want to ensure that the color picker colors match the current color of the materials, which is not done automatically. We also want to ensure the labels match the enabled cosmetic items. For example, if hair 02 is the currently visible hair option, we want the label to reflect that when we open the scene. I will go over how these functions work later. After the ready function, I have all of the signals from the UI, starting with when each color picker is interacted with. In that case, I set the albedo color of each material to the color just chosen by the color picker. I then have the hair left and right buttons, which call the iterate item left and iterate item right functions, which I will review later. When the left and right pants buttons are pressed, we do almost the same thing, except we only iterate the pants item if it is a child of the enabled body node. When we press the body left and right buttons, we want to do the same thing as with the hair, but we also want to make sure all dependent cosmetic items, such as the pants, match the previously visible ones. Once again, I'll go over that function later. Finally, when we press the save and exit button, the node tree is shrunk so that when the character is next loaded, we don't have to worry about a bunch of useless hidden nodes taking up computer resources. We also want to save the now shrunk character tree so that we can load it into another scene, and I then load a new scene. Don't worry, I will now explain how all of those functions I mentioned work. The reset edit label function, called during the ready function to ensure the labels match the enabled cosmetic items, checks every child under the parent node and sets the label text to the name of the first enabled child. The reset edit label dependent function performs the same action on labels for dependent cosmetic items like pants are dependent to the body. It starts at the parent of the pants parent node because we don't know when we call the function which pants parent node to use. It searches for the first enabled body node, then looks through its children for one with the same name as the category argument. In my case, it searches for one named pants, which it will find here. It then searches that node's children for the enabled one and sets the label text to that child's name. My next functions are iterate item right and its left counterpart. It searches for the first child in the children argument that is visible, which, unless you made a mistake, should be the only visible child in that array. It then disables that node and enables either the next node or the first if there is no next node. Iterate item left enables the previous or the last node if there is no previous. They also set the label text for each cosmetic type, like the pants label, to the node's name, like pants 01. I should mention, we could also name the nodes something like jeans or shorts. They do not have to be named pants 01, pants 02, etc. And that goes for all the nodes, like hair and body. We could go with mohawk instead of hair 02. Update dependent item is meant to be called after iterate item left/right on cosmetic items that have dependent ones, like body does. It searches the children array for the node with the same name as item category and searches the children of that node and enables the node with the same name as item name and disables everything else. Shrink is called when the save and exit button is pressed and recursively searches the node tree for disabled nodes and deletes them from the tree. Save puts that shrunk character tree into a global variable you can add to any scene. It also calls build_save_dict, a recursive function that builds the cosmetic items dictionary. Then it copies the cosmetic items dictionary to the global autoload version of that dictionary, global.cosmeticsenabled. Finally, the enable from dict function recursively looks for the node with the name matching the anchor argument, then disable the node's children unless the child's name is the same as the dictionary entry where the key is the same as the anchor. In the global autoload singleton script, I only initialize two variables, global.character and global.cosmeticsenabled, which I reviewed before. The save and exit buttons also load another scene, which in my case is a scene with a button to go back to the editor scene and a node with a script on it that loads the now shrunk character as its child. I hope this tutorial was... Oh, thanks Grammarly. I do want to sound confident. This tutorial was useful to you. No. I hope this tutorial was useful to you. If it was, please consider liking and leaving a comment with suggestions for my next tutorial or video. And if you want to see more content like this, consider subscribing as well. Thank you very much for putting up with this entire video. I do appreciate it.